Did you learn a lot in the last podcast? Oh my goodness. If you haven't backed that first podcast up and watched it again, give your head a shake. The reason why is there's so much information in there, and it's going to apply to this, and it's going to make this so much easier. Check out why. Here's an exponential function, and we're going to make it into a logarithmic function. Yay! Simple, simple, simple. So you know and I know this nice little exponential function has a base of 1/2. So let's go crazy with this base and let's draw it. Here we go. Starting right here. Always start at 0 because you know that any base to the power of 0, of course, is 1. So there's a half. A half to the power of 1 is a half. There's a quarter. There's an eighth. And remember that its sister point way over on the other side of this center line here, of course, is going to be 2, 4, and 8. Oh my, that's just so beautiful. Let's draw it. 0, 1. Everybody knows. Yep, there it is. -1, 2. -2, 4. -3, 8. 5, 6, 7, 8. There it is. Okay. We go to 1, it's a half. We go to 2, it's a quarter. We go to 3, it's an 8, and it just gets smaller and smaller and smaller. So we have an exponential function, of course, we know with a base of 1/2 going in that direction. But watch how fast it is to do a logarithmic function now that we've got this guy done. You know that a logarithmic function is just an inverse. It's an inverse. Okay, so let's go inverse. Okay, why delay? 1, 2, 4, 8. Look at that, inverse. There's 1/2. There's a quarter. There's an eighth. There you go. Draw it. 1, 0. There we go. Okay. 2, -1. 2, -1. There you go. 4, -2. 4, -2. There you go. 8, -3. It's way off the graph, but it's down here. Okay. Then 1/2, 1. 1/2, 1. A quarter, 2. An eighth, 3, and so on. So it hugs this guy, comes down here. Oh, look at this. It actually intersects the graph. Interesting. So there is some sort of common point between the two of them. Ah, pretty interesting. Can you figure out where the common point is? I'll let you worry about that. Okay. So obviously, this is a really, really easy thing to do. Once we've drawn this thing, it's so easy. And we can turn around and we can say, okay, is that in fact a reflection? Well, as a matter of fact, it is. Look, it's reflecting right through that point, right? Right through, look at that. There's your reflection point, right through the center of all of that nonsense based on the y equals to x. Okay, so being that this base is now 1/2, let's put a few more things down here and see what we can figure out. Okay, domain on a logarithmic function. Yes, your x still has to be greater than 0. Remember, you cannot take an exponent, or I should say logarithm, of a negative number. Okay, your range, yep, can be any value of the reals. Okay, x-intercept, yeah, we just found it. Right? It's kind of like the exponent ones, right? Exponent ones are 0, 1. Logarithmic ones are 1, 0. Okay, so the x-intercept is 1. Does it cut the x-axis or the y-axis anywhere? No, does not exist. Do we have an asymptote? Sure we do. Of course. It's this y-axis that doesn't cut. There's our asymptote. So we can put down that x equals to 0. See how simple this is now that you know all of the basis of what we did previously. Okay, go watch that introduction one again. I tell you, it's going to help.